Today we are starting on Module 1, Lesson 16. Yes, we are skipping Lesson 15, we're going straight to 16, and today we're working on word problems. We're going to solve a word problem 2 times. We're going to solve it by rounding and estimating our answer, and then we're going to solve it again using our exact standard algorithm. So take a moment to fill in your table of contents, your next page number, even pause this video if you need to, and when you're ready, find that next blank page to start your notes on. Let's take a look at our objective today, and you're going to notice that I boxed a very important word to us. Our objective says I can solve multi-step word problems and assess reasonableness using rounding. Multi-step word problems means that we have multiple steps. Maybe we'll add twice, maybe we'll subtract twice, maybe we'll add and then subtract, or subtract and then add. Reasonableness is a mathematician's word. That means that our estimate and our exact answer are close together and very accurate. Remember that we're going to be solving this problem 2 ways. The first way we'll be using our rounding skills, and the second way we'll be using our exact numbers. If these 2 answers are close, then that means that our answer is reasonable and is probably accurate. If these 2 answers are totally different from one another, then it probably isn't reasonable and we might not be accurate. So we're going to decide once we get our answers if it's reasonable. With a word problem, we have to read it, we have to draw it, and we have to write our answer. So let's start with the reading. Zachary's final project for a college course took a semester to write and had 95,234 words. Zachary wrote 35,295 words in the first month and 19,240 words the second month. Round each value to the nearest 10,000 to estimate how many words Zachary wrote during the remaining part of the semester. Find the exact number of words written during the remaining part of the semester. Okay, I read it, but I'm not done with my R step, because remember, to be a beast at word problems, you have to start off as a cub. C-U-B. To really get the information soaked into our brains, we're going to circle the numbers and units, underline our question, and box our clue words. So let's take a close look at this word problem and start with circling the numbers and units. Zachary's final project for a college course took a semester to write and had 95,234 words. Zachary wrote 35,295 words the first month and 19,240 words the second month. Round each value to the nearest 10,000. I know that this is in word form, but I'm still going to circle it because I think it'll be important to us. To estimate how many words Zachary wrote during the remaining part of the semester. Find the exact number of words written during the remaining part of the semester. Now that I have circled my numbers and units, I'm going to underline the question. Here's the part that's a little tricky for me. My helpful trick is that I look for the question mark in a problem and I underline that sentence, but I don't see any question marks. And that's going to happen to you pretty often. In word problems, if you can't find a sentence that ends with a question mark, instead look for the sentences that are telling you to do things. For example, it's telling me to round each value to the nearest 10,000 to estimate how many words Zachary wrote during the remaining part of the semester. Just like my question tells me to do something, this sentence is also telling me what task I have to do. Remember though, we're solving this problem 2 times. So that means I have to underline another task that they want me to do. After I find the answer by rounding, I'm also going to find the exact number of words written during the remaining part of the semester. And now I'm ready to box off U. Next, I'm going to box clue words. Those are the words that tell me if I'm rounding or using exact numbers, words that tell me if I'm adding or subtracting. Zachary's final project for a college course took a semester to write and had 95,234 words. Zachary wrote 35,295 words the first month. I'm going to box first. And 19,240 words in the second month. The numbers first and second give me a clue that I might need to do some combining of those months. Round each value to the nearest 10,000. I'm going to box nearest because that's a rounding term. To estimate, all kinds of clue words. How many words Zachary wrote during the remaining part of the semester? Remaining, like the word remainder, tells me what's left over. And if I'm finding leftovers, I'm probably going to be doing subtraction. Find the exact number of words written during the remaining part of the semester. Now that I've boxed my clue words, it's time for us to draw on a tape diagram. We're going to solve two ways, first by rounding, and then again by using exact numbers. We already have some tape diagrams laid out for us, but remember that we have to round to the 10,000s before we do any adding or subtracting. This first tape diagram shows us how many words he wrote in the first month, but it's written as an exact number. I see my swirly little equal signs, which tells me that I'm going to be estimating. I'm rounding in the 10,000s, which means in the number, I have to box my 10,000s place. The number in the box is the number that I'm rounding. Ones, tens, hundreds, thousands, 10,000s. Even though I boxed the 3, it's not exactly the star of the show. Remember, I look to its neighbor in the next lowest place value to tell me if I'm rounding up or if I'm going to stay at 3 10,000s. 5 or more means I round up. So the number in my box goes up one number, a 3 becomes a 4, and everything else becomes... Oh, I hope you were saying 0 in your head there because you would be correct. After the box, I'll have 1, 2, 3, 4 zeros. 1, 2, 3, 4. Let's 1, 2, 3, wee. 1, 2, 3, wee! 40,000 in the first month. Let's do it again for our second month. Ones, tens, hundreds, thousands. Box our 10,000s. But look to our neighbor to see if we're rounding up or staying at 1 10,000. 9 is greater than 5 or more, so I'm rounding up. 1 becomes a 2. And everything else becomes... Man, I hope you said zeros. 1, 2, 3, 4 zeros come after the box. Let's 1, 2, 3, wee. 1, 2, 3, wee! I don't know how much he wrote in the rest of the semester. That's why we have a question mark there. We have to find the leftovers of the semester. But what we do know is how much he wrote in total. So let's round that number. I'm going to, again, box my 10,000s, circle its neighbors. We got a lot of rounding up going on. 5 tells me I'm rounding up. The number in the box goes up 1. 9 becomes 10. And everything after the box becomes zeros. 1, 2, 3, 4 zeros. 1, 2, 3, 4. Let's 1, 2, 3, wee. 1, 2, 3, wee! All right. We even made it to the next place value because our 9 became a 10, and 10 10,000s is the same as 100,000. To figure out how much he wrote at the end of the semester, I'm thinking of part, whole. My whole number is 100,000, but I actually have 3 parts. I have 40,000, 20,000, and this mystery part. Let's combine these two together so we can have part, whole. I'm going to set up a standard algorithm addition sentence so that I can add those 2 months together. Even though I'm getting really good at addition, I'm still going to practice drawing vertical lines to separate my place values out. 0 plus 0 equals 0. 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 And 4 plus 2 equals 6. 1, 2, 3, wee! In the 2 months combined, he wrote 60,000 words. Remember, this is a multi-step problem. This is just one step. So to solve, I have to do another step. I need to figure out what's remaining. If he wrote in total 100,000 words, and he already wrote 60,000, let's do another step where we take away 60,000 from 100,000 to find what's left over. I'm going to start by writing the number 100,000 at the top, and I'm going to take away 60,000. I need to be really careful with my place values because I actually have less digits in the number 60,000 than I do in 100,000. Remember, if there is more on the top, no need to stop. If there's more on the floor, we need to go next door and get some more. But what if the number on the top and the bottom are the same? Well, that just means that we're taking away the same number, which leaves us with 0. 0 minus 0 is 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 0. 0 minus 6 is more on the floor. If there's more on the floor, we need to go next door and get some more. Now I have more on the top. 10 take away 6 is 4. 0 take away nothing is 0, and I don't need to put a 0 in front of my place values. So let's 1, 2, 3, wee. 1, 2, 3, wee! Zachary wrote about 40,000 words when we use our estimation skills. Now for this one, we're doing the same exact process, except we won't be rounding. Instead, we'll be using exact numbers. So instead of taking the time to round each to its place values in the nearest 10,000, we're actually going to go to the first step of combining our 2 months together so we can have a true part-whole subtraction sentence. So I'm going to set up an addition sentence where I add how many words he wrote in month 1, 35,295, with how many words he wrote in month 2, 19,240. I know we're getting really good at addition, but I'm still going to practice separating out my place values. 5 plus 0 equals 5. 9 plus 4 equals 13, so I need to regroup 1 extra in the hundreds place. 2 plus 2 equals 4, plus 1 more equals 5. 5 plus 9 equals 14, so again, I need to leave behind the 4 and regroup an extra 10,000. 3 plus 1 is 4, 4 plus 1 is 5. 1, 2, 3, wee! When we rounded, we had about 60,000 words combined in those 2 months. When we're finding the exact numbers, it was 54,535. I mean, we're pretty close, but if I rounded up 54,000 to the nearest 10,000, it would be 50,000, not 60,000. So I'm getting a little nervous about my reasonableness here. Remember, reasonable means that our exact answer is close to our rounded answer. But let's not get ahead of ourselves. Let's do our second step in the multi-step problem and see how reasonable our answer becomes. Remember, after we combined those months, we subtracted it from the total amount of words he wrote all together. So I'm going to set up a subtraction sentence that says 95,234, and I'm going to take away 54,535. I'm being super careful to line up my place values. And again, I have my lines to keep me nice and straight. Remember, more on the top, no need to stop. 4 minus 5, there's not more on the top, there's more on the floor. And if there's more on the floor, I need to go next door and get some more. $14 take away 5 is 9. Now we'll move over to the tens place. More on the top, no need to stop, but now that there's a 2, there's more on the floor. So if there's more on the floor, I need to go next door and get some more. The 2 that I regrouped becomes a 12. 12 minus 3 equals 9. All right, let's keep pushing through. More on the top, no need to stop. But in our hundreds place, we have more on the floor. So if there's more on the floor, we're going to go next door and get some more. Our 1 becomes an 11. 11 minus 5 equals 6. 4 take away 4, there's not more on the top or more on the floor, but I know if I'm subtracting the same number, I just end up with 0. 4 take away 4 is 0. 9 minus 5, there's more on the top, no need to stop. 9 take away 5 equals 4. 1, 2, 3, whee! He wrote exactly 40,699 words. So let's go back to our read, write, draw. Before we start talking about what's reasonable or not reasonable, let's check our steps for word problems. We drew out our tape diagrams. We showed our work. In fact, we even took the step of plugging in our answers into a complete sentence. So we've done all of read, draw, write. We're just left with one question. Is our answer reasonable? Meaning, is it accurate? Is the estimate close to the exact number? And I can say confidently, looking at 40,000 and 40,699, that these are reasonable answers because they're pretty close to each other. So in our top box, is your answer reasonable? We can write, yes, it is, let's practice writing that word, reasonable.